This week we're focusing on geometry. This week is a much smaller set of standards, but equally as important as everything else that we've covered, as it extends into what we already know about geometry from previous grades and just continues building on, just as everything else has. So in previous grades, we found the area of many different shapes. In 6th grade, we can find the area of a figure by decomposing it into other shapes. So we have some irregular shapes here that we need to find the area of. When I look at these, I guess I'd call them an L shape of sorts, I could break them into two different rectangles. So I could have a rectangle, the top piece and a bottom piece. I'll call them rectangle 1 and rectangle 2. Note that just because I cut mine this way doesn't mean that you couldn't rotate, oops, not that one, doesn't mean that you couldn't rotate this and cut here to have a 1 and a 2. There's no right or wrong way to do this. This is just how I saw it right away first, based on the numbers that are given to me, so that I wouldn't have to combine any together. So the area of the first rectangle is 4 times 5, which is 20 feet squared. The area of the second one is 16 times 6, so 96 feet squared. So if I were to add their areas together, we would get a total of 116 feet squared. So looking at our second option, I'm going to cut again horizontally. You could cut vertically, that's completely fine. I didn't cut vertically just because of this length of 9 5/10. If I were to cut this way, as an example, I would have to figure out what a portion of this length is. So I would have to take 9 5/10, subtract 5 to get 4 5/10 here. I just didn't want to do that, but you certainly could. So the area of the first one here is 5 feet times 12 feet. And I got 12 feet because this whole length is 15 from top to bottom, but we cut it off at the 3-foot mark. So there are 12 feet here that we still need, that is still left over. So 5 times 12 is 60 feet. The length of our second or area of the second rectangle is 3 feet by 9 5/10 feet, which is 28 5/10 feet. So if I were to add their areas together, we would get 88 5/10 of a foot. So let's find the shape of this backward Z area. They give us a bunch of different information. So I'm going to cut it into 3 different rectangles. Again, you could cut them a little differently than myself, but this is the way I decided to cut them. So the area of the first rectangle is 6 by 3. And I got 3 for this length here, or you could say this length here, because I know that this piece is 19, plus 3 more would get me to 22. So 6 times 3 is 18 inches squared. The area of the second one is 17 by 5. So I see that this is 17. This whole length is 11, but a portion just right here is 6. So 6 and 5 would give us 11. So 17 times 5 is 85 inches squared. And then the last one here, 9 by 5. So I knew that this here was 9 inches, and then to figure out this length, I used 17 plus 5 more to get to 22. So I use this 22 quite often, and 9 times 5 is 45. So the total area is 18 plus 85 plus 45, so 148 inches squared. A group of students designed the sidewalk surrounding the pool. We need to determine the total area covered area covered by each color, and the cost. So they designed using the design below, and they give us the dimensions of the tiles and how much each of those tiles cost. So the area of the blue square is 3 by 3, so 9 feet. We have 12 of those blue ones by counting. 1, 2, 3, 4, so here would be 8, 9, 10, 11, 12. So the area of 1 times how many we have, so 108 feet squared of blue. The area of a yellow rectangle is 3 feet by 6 feet, so 18 feet. And we have 1, 2, 3, 4, 5, 6, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, and 22. So we'll take that 18 feet squared and multiply it by 22 to get 396 feet squared. The area of the purple is a 6 by 6, so 36 feet squared. And we have 1, 2, 3, 4, 5, 6, 7, 8 purples. So 36 feet squared times 8 is 288 feet squared. The total area covered by these pieces is 108 plus 396 plus 288 plus 792 feet squared. The total cost then would be $8. So the blue ones they're $8 a piece, and we had 12 of them. The yellow ones are $14 a piece, and we have 22 of them. And the purple ones are $18, and we have 8 of them. So for a total of 8 times 12, which is 96, 14 times 22, which is 308, and 18 times 8, which is 144. So adding it all together, we get $548. Oops. Similarly, we can find the area of a figure by relating it to the area of other figures. So find the area of this triangle. So the area of a triangle is half times base times height. Well, we can relate this triangle to a rectangle. So a triangle is exactly half of a rectangle, and we know that the area of a rectangle is base times height, so we just need half of it. So our base and height is 9 units and 12 units. So when we multiply them all together, oops, went a little too fast, 54 square units. The triangle here on the right, if I were to cut it down the middle in half and fold out the edges as such, we have created a rectangle. So even though it doesn't seem like it could be a perfect a rectangle, every triangle can be made into a rectangle. So the area still holds the same, half times base times height. So I gave us 18 and 6 centimeters, giving us 54 centimeters squared. So let's find the area of this rectangle. Notice how it outstretches a little bit on the right-hand side, just past the bottom corner. What we could do is fill in the remaining corner here, and let's say it's 6 units by 4.5 units. It is still half of the base times the height, so the base is 6 and the height is 4.5, for a total of 13 and 5/10 square units. We can do this because we have related our new figure to a figure of a known area as a rectangle. What is the relationship? We can find the area of a parallelogram and trapezoid by relating to rectangles and each other. What is the relationship between the area of a parallelogram and the area of a rectangle? So notice I kind of cut down the middle here, like so. I'm going to slide that piece over to the right-hand side, which will then create a square. So the area of a parallelogram is base times height, just as a rectangle or square would be. So if our base is 8, or excuse me, if our base is 7.5 and our height is 8, we have 60 square centimeters. How about a trapezoid? So there's a bunch of different steps here. This first step is to bring in another trapezoid and bring it down, which we've then created a parallelogram, but we only want half of that parallelogram. And we are concerned about the particulars because one side is shorter than the other side here. So we get them by finding half of base 1 plus base 2 times the height. So we have this parallelogram here whose bases are 16 and 8. So we want to add them, and the height is 7, giving us 84 square units. Determine if we have enough lights to go around the tent that we are renting for our classroom party. So we need to know the perimeter of this rectangle. So in order to do that, we need to know what the length is of the long side and the length of the short side is. If you notice here, we have a large trapezoid, and we know how to find the area of a trapezoid. We just went over the formula. It tells us that the total area is 540 feet squared. One of the bases is 20 feet and the height is 18. So if we plug them in to our formula, the area is 50 times half of 20 plus b plus 18. I can do half of 18, which is 9, because we know that we can multiply in any order and it's still going to give the same result. I then know, using the distributive property, that 9 times the quantity of 20 plus b will be 9 times 20 plus 9 times b, giving us 180 plus 9b. Using the inverse of addition, we subtract 180, giving us 360 equals 9b. The inverse of multiplication is to divide, so the base is 40. So then I kind of drew a rectangle up here to signify the top of our tent. So I know that this length and this length are 40. Now we need the corners of our tent, which are triangles. The area of a triangle we know is half times base times height. We know the area, which is given, and we know the height of our triangle is 18 feet. So 270 is half times base times height. We don't know what the base is. Half of 18 is 9. Using the inverse of multiplication, we divide by 9. So b is equal to 30. So then each one of our end pieces of the tent will be 30. Well, now we need to know the perimeter of the tent. So we add all of our sides up together, and we see that the perimeter is 140 feet. It looks like we have 150 feet of lights. So our lights are 150, which is greater than the space needed of 140 feet. So yes, we will have enough lights to go around our tent. The volume of a rectangular prism can be found by filling it with cubes or using the formula volume is length times width times height. What are the volumes of these rectangular prisms? So volume is, starting with the purple one here, 1.5 times 2 times 2.5. I then converted them into equivalent fractions, and knowing that 1 and 1/2 is the same as 3 copies of a half, and 2.5 is the same as 5 copies of a half. So I could multiply more easily. So when I multiply, we get 30/4 or 7.5. On the right, we have the volume of a half times 4 times 1, which is 2 times 1, which is also 2 inches cubed. So notice then I also put in the inches cubed over here. We are in volume, and because we're multiplying inches times inches times inches, we're multiplying it 3 times, our volume is then represented in cubes. so inches cubed, whereas area is in squares. A net is another way of representing a three-dimensional figure. A net allows us to see all of the faces of the figure at once. Let's learn to draw the nets of the following figures. So we'll start with the pyramid here, the square pyramid. So we're going to first draw the polygon base, which is a square. And then you're going to draw one triangular face on each side of the polygon base. And you want to check these sides here to make sure that they are congruent. So when we fold them up to create the pyramid top, that they are able to connect with one another. Similarly, with the rectangular pyramid, we'll draw the rectangular base. We will draw a triangular face on each of the polygon bases. And notice that because of the length of here, that our triangles will be slightly different. So, but we still need to make sure that these sides here are congruent. So when we fold them up, they will meet. Okay, then we have the rectangular prism. So we will draw the rectangular prism base here. We will draw one rectangular face connected to each side of the polygon base, here, 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 and here. Check the rectangular sides to make sure these are congruent. So these cutout pieces, and then draw the second polygon base connected to one of the rectangles. And it says connected to one because you could have connected it to the top here, the side, or the bottom. Similarly, with the pentagonal prism, and it's a pentagonal prism because we have a pentagon, and it's a prism, not a pyramid, because it doesn't meet at one point like the pyramids do. So we'll draw the polygon base of the pentagon. We will draw a rectangular face connected to each side of the polygon base. And then we check to make sure that the rectangular sides where those arrows are will meet together, are congruent. And then we need to draw the second polygon base connected to one of the rectangles. I don't have it drawn here, but you would also need to create a pentagon off of one of these here, so that when you fold it, we'll have a top. Which of the three-dimensional figures is represented in the net shown? Is it a triangular pyramid, a rectangular pyramid, triangular prism, hexagonal pyramid, hexagonal prism, octagonal pyramid, or an octagonal prism? It is a hexagonal pyramid. We have a hexagon in the middle, or as our polygon, and if we were to fold these all together, it would come up to one point, so it's a pyramid. Which three-dimensional figure is represented by the net shown? Is it a triangular pyramid, a rectangular pyramid, a rectangular prism, or a triangular prism? This is a rectangular prism. I would fold each piece of these up, and then this part would snap down and match here, and this part would match down here, so it creates a nice prism. But it shouldn't be a rectangular prism. No, it would be a triangular prism. So we need to not highlight this one. Perfect. Triangular prism. Fill in the blanks. An octagonal prism has how many bases and how many faces? A rectangular prism has how many faces that are what shape? An octagonal prism has two bases. The bases are each octagons, and we would need 8 faces to finish them, one for each side of the octagon. A rectangular prism has rectangular faces that are rectangles. One sheet of poster board measures 18 by 24 inches. How many sheets should Mr. Nelson buy so that all 5 teams of students can build one of each figure? We're going to decompose each one of our shapes so that we can find the total area or surface area that each net consists of. So I'll start with the rectangular prism here. We have 4.5 by 2 to get this space here, which is 9 square inches. We have another one of those at the top, so 4.5 by 2. We have 2 that are 4.5 by 6, so 4.5 by 6, 4.5 by 6. We have one that is a 2 by 6, and another one that is a 2 by 6. So all together, when we add these, we have 96 square inches. Let's move to the triangular prism. We have 2 triangles and we have 4 rectangles. So if we start with the triangles, the area of a triangle is half times base times height. So half times the base of 4 times the height of 3.5, which is 7. We have 2 triangles, so I wrote that one twice. Then we have a 4 by 6.5, another 4 by 6.5, and the middle is a 4 by 6.5. So this one is 92 square inches. And then we have the square pyramid. We'll start with the square in the middle, which is 7 by 7. And then we have 4 triangles surrounding our square. So half times 7 times 7. And 3 more of them. So altogether, this square pyramid is 147 square inches. Altogether, then, we have a total of 96 plus 92 plus 144 for 335 square inches. Well, we have 5 teams, so we need to multiply their areas by 5 teams. So we need 1,675 square inches. The poster area given up above is 18 by 24, so that is 432 square inches. So we'll take how many total that we need divided by the poster area. So we have about 3.87 blah 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 sheets of poster board, which we'll round to 4 just to make sure. So each team will need 4 sheets of poster board. Select the formulas needed to find the surface area of each 3-dimensional figure. You may select one or both formulas. Take a moment to pause the video and we'll talk about the results. So a cube has all 4 sides, which are a square or a rectangle. So we would only need base times height. If we have a rectangular prism, we would also only need a base times a height because all of our sides would be squares or rectangles. When I look at a triangular pyramid, we would need the area of a triangle formula. And I have a picture on the right here. So it's a triangular pyramid because the triangular part tells us that it's a triangle base, and a pyramid means that they're all going to meet at one particular point. So all we have are triangles versus a square pyramid where we would need both. So our base is a square, but notice that we would need triangles in order to make the pyramid portion. And then a triangular prism, we would need both of them because we would have 3 rectangles and then 2 triangles for the bases.